Welcome to Rao's IAS Focus Weekly. Today we are going to talk about the current affairs in the subject of science and technology in the past 1 week. I have covered the topics from 30th of January 2025 till 5th of February 2025. Now, these are the major topics that were there in the past 1 week, popularly discussed. We'll start with the topic of sustained nuclear fusion. You must have come across to news related to how China has successfully tested a sustainable fusion reaction and they have registered a world record in this. We'll talk about it in detail. Then we'll discuss the next generation launch vehicle that has been planned by ISRO. What are going to be its expected what are going to be its expected features, what makes this unique or much more capable than past missions or past launch vehicles. We'll talk about that. Then we'll discuss a solution to forever chemicals. This is somewhat overlapping with environment pollution. So forever chemicals, what are these? How we have been able to find one possible alternative to forever chemicals. We'll see that. Then we'll talk about the Indian naval sailing vessel Tarini and what is why it is in news, what has been the recent achievement of INSV Tarini. Then we'll talk about non-opioids painkillers. There has been a recent development in non-opioids painkillers. They are basically painkillers that are not derived from opium or narcotic substances. So we'll see what has been the development in this. Then we'll talk about some recent research and outcomes of Asteroid Bennu. It has been there in the news in the past 1 month, in fact, but we have taken it because of the recent development that has been popularly discussed in the news in the past 1 week. Then we'll talk about small modular reactors and what has been the initiative related to small modular nuclear reactors in the Union Budget 2025. Then we'll talk about AI driven genetic testing. What are the issues related to it? What is the current situation? And this is again related to the Union Budget 2025. We'll see this development also. And then we'll talk about the very short range air defense system that has been recently tested by DRDO. What has been its achievement, what are its popular features, what system we had earlier, and what innovation that we have registered in this recent testing. And then we'll also talk about the dengue warning system that has been recently developed by IITM Pune and what predictions have come up from this dengue early warning system. We'll talk about them. So let's start with the first topic of our discussion, that is the recent news on the Chinese nuclear fusion reactor. Right now, guys, to start our conversation on this topic, we all understand that today we are all looking for alternatives to fossil fuels and finding sustainable energy solutions for future, right? So this is not a surprise for anyone that the future belongs to sustainable and renewable energy sources. Now, when it comes to the aspect of sustainability, nuclear energy is found to be one possible alternative to fossil fuels, especially coal. Of course, nuclear energy is not considered to be renewable because renewable energy by definition is the energy sources which is regenerated at the end. Like solar energy, the sunlight is constantly available to us and we convert that sun's energy into electricity or some other purpose. We can convert it into heat energy, we can convert it into electricity. But solar energy is always available. It does not take any time to recharge, right? So it is naturally available. Wind is also naturally available to us. Water flowing in the river is naturally available. So these are considered to be renewable forms of energy. Nuclear energy per se is not considered to be renewable because in all kinds of nuclear reactions, whether it is nuclear fission or nuclear fusion, the reactants involved are lost in that process and it produces a different kind of product. You can't recover the same reactants. Like for example, if you talk about nuclear fission, which involves uranium, and we bombard a high-speed neutron into uranium and uranium splits into smaller nuclei, you can't get uranium again. Similarly, the other type of nuclear reaction is called nuclear fusion, where you combine two smaller nuclei of hydrogen, two isotopes of hydrogen. We take deuterium as one of the isotope and tritium is another isotope. So we take two isotopes of hydrogen, combine it with each other, create helium as the product. In this process also, hydrogen is not being produced. So in no circumstances nuclear energy is considered to be renewable. But where nuclear energy is seen as the future of energy is in its carbon footprint. It is a type of energy source that does not emit any carbon footprint, does not release any carbon, and that makes nuclear energy a very good, a very tentative or very possible alternative to coal or fossil fuel. So nuclear energy is bound to stay with us. Consider this as going to be an important replacement to coal-based energy, because it's obvious renewable energy is best. When I talk about renewable energy, we normally talk about wind, solar, hydroelectricity, or to a certain extent biofuel. So all these energy sources are renewable, right? But the problem is all these energy sources are bound to, they are not consistent. They are bound with intermittencies. So the supply of solar energy is not available 24 hours. So as wind, so as biofuel, because biofuel mostly depend on agricultural seasons. So whenever there is an agricultural season where we get a good amount of agricultural waste produced, we often see a lot of, biofuel sources generated. But with nuclear energy, because all these renewable energy are intermittent, they are not available throughout the year, equally distributed on Earth in the same intensity. That is why nuclear energy becomes one reliable source which does not produce carbon, which does not emit carbon footprint, but at the same time can be made available on Earth everywhere with same intensities. So nuclear energy is going to be one good replacement of fossil fuel and a much more reliable one compared to renewable energy. But remember, do not make this mistake. Nuclear energy is not considered to be renewable. But when you talk about nuclear fusion in particular, this is in fact some kind of energy which is even better than renewable energy, right? So let's talk about what exactly is nuclear fusion. So guys, what recently China has achieved, this is the first time we are having a conversation on nuclear fusion on Focus Weekly. So I'll try to make it a little detailed, but also try to keep the extent of UPSC in mind. So guys, when you talk about nuclear fusion, this is a method of producing nuclear energy. We already see this nuclear fusion happening in weapons. Like you must have heard of something called hydrogen bomb. A hydrogen bomb is simply a bomb which involves two isotopes of hydrogen. Isotopes are basically elements which have same atomic number but different mass number. So we take two isotopes of hydrogen, let's call it deuterium and tritium, and we somewhat put a high pressure and temperature around them so that both the isotopes of hydrogen fuses and produces helium. In this process of nuclear fusion, it generates a lot of energy. This energy is so massive that the sun's energy is sourced from this fusion reaction only. So you can just imagine the sun itself is nothing but a giant uncontrolled nuclear fusion reactor. So in case of hydrogen bombs, we are trying to replicate the sun's energy already on Earth. And this has been successfully performed. We have performed the same reactions even in India also. So in terms of nuclear weapons, nuclear fusion reactions are already there with us in the past 70 years, they are already there. But in the recent years, there have been massive global attempts to replicate nuclear fusion reaction in order to produce sustained or sustainable energy for power generation in future. Although, mind my words, nuclear fusion into power generation is still a distant dream, because nuclear fusion involves high pressure and temperature. And when you need high pressure and temperature to trigger a nuclear reaction, this high pressure and temperature is very difficult to attain on Earth. We see this high pressure and temperature attained on the sun. We see this high pressure and temperature attained in a nuclear fusion bomb. But to produce it in a controlled manner so that you can sustain this energy for a long period, this has never been performed, for a very long period. But like I said, this has never been performed so far. Many countries, including India as well, are working extensively to replicate nuclear fusion reaction, and that to control its energy output. Because it is believed that nuclear fusion could be one possible solution for future energy demand. It can help us to attain 100% green energy without the worry of any kind of resource depletion. Why did I say resource depletion? Remember, even when I talk about biofuels are produced from agricultural waste, organic waste around us, right? Nuclear fusion works on hydrogen, where we take two isotopes of hydrogen, let them fuse and produce helium and energy. What if I tell you universe is nearly 75% made up of hydrogen. 75% of the entire universe, I'm saying, guys. That means wherever you go in this universe, not just our planet, not just other planets, not just our solar system, not just our galaxy, everywhere where you go in this universe, you are very likely to find hydrogen. So this is one source, this is one fuel that is most abundantly available on Earth. It is most abundantly available in the universe. So hydrogen is often seen as a future fuel. Nuclear fusion reactors could be one possible way of harnessing hydrogen-based energy into future sustainable power. I hope all of you guys have been able to understand. So what China has done recently, they have been able to develop a nuclear fusion reaction. Mind my words, China is not the first country to do this. These nuclear fusion reactors are already developed in USA, they are already developed in Russia, they are already developed in UK. In fact, there is a global initiative with the name ITER, International Thermonuclear Experimental Reactor, in which India is also a partner. It's an initiative of 35 countries of Europe and other 6 countries out of Europe. And these 35 countries are already working in creating a sustained nuclear fusion reaction in the name of ITER. It's called International Thermonuclear Experimental Reactor. So what China has done, China, by the way, is also part of the same initiative. China is also part of ITER. So what China has done lately, they have been able to replicate the nuclear fusion reaction. And what they have done, what they have done new here is that they have been able to perform a nuclear fusion reaction and sustain it for nearly 18 minutes. This has never happened before. They have been able to perform it and sustain it for nearly 18 minutes. The previous record, before this was nearly 6 minutes, right? Nearly 6 minutes was the previous record, almost 400 seconds. And they have been able to do it for almost 18 minutes, right? So one can easily understand we are slowly moving towards a much more sustained nuclear fusion reactor technology. And once we are able to reach this, it will open us a window of energy security for the next millions of years. Mind my words, guys, it's not an exaggeration when I use the word millions of years. It will really provide us energy that can sustain for the next millions of years. I hope you guys are able to get it. So what is this name of the reactor? The name of the reactor is EAST, Experimental Advanced Superconducting Tokamak. Tokamak is the reactor name. It is a Russian name in origin and it has been used for nuclear fusion reactors very popularly, right? So EAST is the name of the reactor. It is located at the Institute of Plasma Physics at Anhui province in East China. So China has been able to conduct this particular reaction for 18 minutes. This is basically the unique achievement that the Chinese have made. And what type of reaction technology they have used? So guys, when it comes to nuclear fusion, like I said, nuclear fusion basically involves hydrogen. So this is one isotope of hydrogen, we call it deuterium. Then there is another isotope of hydrogen, we call it tritium. They both are basically made to combine with each other. Now to combine them into each other, we require high pressure and high temperature. And when this sufficient pressure and temperature is applied, they both are found to be fused into helium. This is helium, atomic number 2, mass number 4, plus one more neutron is produced. One neutron is emitted, and alongside with this, it produces a lot of energy, right? It produces a lot of energy, nearly 3.5 million electron volt of energy is produced in this single reaction. So this is the kind of reaction that happens, and to perform this reaction where deuterium and tritium combines, we require high pressure and temperature, right? So a nuclear fusion reactor is simply a reactor that provides these conditions, high pressure and temperature, so that two isotopes of hydrogen can fuse. The two atoms of hydrogen, they both can fuse into each other and produce helium and release a massive amount of energy. So this is basically the concept of nuclear fusion. Now what is unique about this Chinese experiment is, guys, when it comes to this high pressure and temperature, what we have here, so this is how in general how this reactor looks like. This is a simple diagram of this reactor. This is an actual footage of the reactor. It has been captured in 2018. This was the image that we found, and this has been the place where this experiment has occurred. So I'll first tell you a few things what they have achieved recently, and then I'll tell you how they have been able to achieve it, right? So they have set a new world record by maintaining a plasma state for 1000 seconds, nearly 18 minutes. Now this is something very interesting, guys. Now let us try to understand what this really means, what they have mentioned here. So if you notice, they have used the word plasma state. So basically the idea is, like I said, remember the trigger condition for nuclear fusion. It is high pressure and high temperature. High pressure and high temperature is the condition. So if you want to replicate a nuclear fusion reaction on Earth, you need to have high pressure and temperature provided. That's the bottom line. You need to have high pressure and temperature. So the concept of providing high temperature and pressure is basically to convert the hydrogen isotopes, deuterium and tritium, into its plasma form. What exactly is plasma? Plasma is basically high temperature ionized gases. High temperature ionized gases. So basically what we do, we basically heat up the hydrogen to such an extent that hydrogen gets so hot that it loses all its electrons out in the space, and whatever is left is nothing but charged atoms of hydrogen. I hope you understand. Ionized gases means charged atom, and ion simply means charged atom. So whenever an atom gets a charge, it eventually converts into ions, and when it happens due to very high temperature, it becomes plasma. So plasma is technically a fourth stage of matter. We have three states of matter that most of you must be knowing. We have solid state, liquid state, gaseous state. Plasma happens to be the fourth state of matter, and this plasma is produced when the temperature, when the gases are heated to such an extreme temperature that all the gases gets ionized, and this high temperature ionized gas is called a plasma. Now, how this plasma is produced is the basics of the technology. So some countries have different methods of producing it. So guys, in terms of nuclear fusion, I'm trying to cover every aspect of nuclear fusion here. So it may take a little longer, but you guys should be able to understand that's an important part. And do please make sure that you write in the comment. Let me know if you are still having a difficulty in understanding this. I'll be happy to help you out. We can cover up this topic again n number of times, right? We have no dearth of time in this. So when it comes to this aspect of plasma, so all of you have understood that we have to fuse hydrogen and hydrogen into each other. Now there are two methods normally that we use to fuse them, right, which are tested method, right? Although there could be a third method also, but I'm going to talk about only the two methods that have been successfully tested so far. So one method is called magnetic confinement. You know, this word confinement comes a lot when you talk about nuclear fusion energy. This word confinement comes a lot. So one method is called magnetic confinement. In case of magnetic confinement, what we do, we put a large electromagnets all along the reactor, and we apply a very strong electromagnetic force, and this electromagnetic force is kept so strong that until hydrogen isotopes, or this hydrogen ions, or this hydrogen plasma, when it is applied with a very strong electromagnetic force, all this hydrogen plasma, it gets pushed closer and closer to each other, and because it is also charged, so it will respond to electromagnetic field. So the electromagnets are going to apply a strong force, and all these charged particles are going to keep on moving to each other, and as the density of the plasma keeps increasing, the chances of its fusion also increases. Right? So the concept is very simple. You are applying an incredible amount of force that fuses two particles into each other, and that force in the case of magnetic confinement is electromagnetic force, and the particles that are being fused are nothing but charged particles. I hope you guys are able to get it. As simple as this, right? So this is called magnetic confinement. Guys, the word confinement is used in order to hold the plasma. So how you are holding the plasma, how you are pushing the plasma into each other, it's what is called confinement. And guys, mind my words, why this 18 minutes achievement is so incredible? Why is this 18 minutes of maintaining a nuclear fusion reaction is so incredible? Is because this plasma, you know, if you do not apply a strong inward acting force to hold the plasma, this plasma have a very high tendency of cooling down, because it will have a tendency to expand, and as it expands, it will cool down in a moment. It will cool down in seconds. So it has a very high tendency of, you know, cooling down very quickly. So we have to apply a very strong external force to keep it intact. We have to apply a strong external force to keep it intact. So that's basically the idea behind this magnetic confinement. So in magnetic confinement, we put a very strong external force to hold it together. Now, other than magnetic confinement, there is another type of confinement which the Chinese have used, which this particular reactor has used. It's called laser confinement. It is called laser confinement. So you can see in this image, they have used high energy laser beam. So instead of using electromagnetic, electromagnets, they use high energy lasers. Now what are lasers? Lasers, you can consider them as high energy light only. Lasers are basically light which have a very high energy. You all have played with lasers. They are very concentrated. So when you fire a laser at somebody, it was always a concentrated beam of light. And this concentrated beam of light, it has very high energy. You guys must have noticed there are laser cutting tools available which can cut through metal. There are laser grafting tools available which can actually graft and produce, they can cut through stones, cut through rocks and give you different kinds of designs. So lasers could be highly energized. So what we have done, we have taken hydrogen plasma at the center, and we supply such incredible amount of laser energy that this plasma remain confined, and as the laser keeps putting it high temperature, it eventually fuses. And that's what matters here. So what the Chinese have done actually, and one more incredible fact, guys, the same laser confinement was demonstrated in the year 2023 by an American laboratory. So Chinese have basically taken the same concept of the Americans that they were able to achieve in 2023. That was nearly 5 to 6 minutes. Chinese have been able to do it for 18 minutes, 3 times longer than what the Americans did. So this is definitely a big achievement. I hope all of you guys are able to understand. So this could be a source for providing limitless and clean energy source. Guys, one more point. They have maintained this plasma to a temperature of 100 million degrees Celsius. Guys, the temperature of the sun's interior is 20 million, close to 20 million degrees Celsius. They have been able to achieve a temperature 5 times higher than the sun's center. So this is obviously a big achievement, right? Any country could have made. So this is what we have under the Chinese achievement or the Chinese development, and why it has been used, you guys can easily predict. Now, what are the concerns of this achievement for India? Right? Considering the geopolitical situation, guys, there is no doubt if a massive development happens in China, we can't ignore it in India because we have to be prepared, right? So it's not like, that India is very far in this. India is also part of the ITER initiative, and as the ITER initiative, which is also planning to replicate the same in nuclear fusion reactor technology, it is also expected to be finished by this year end. So by this year end, we may end up discussing something so significant that you may see India's contribution in the world of nuclear fusion. What Chinese, and guys, it has been also the stand of the government. Prime Minister of India himself has mentioned that India will also work on its indigenous nuclear fusion reactor. We have already been working on this program since 1989 also, but our indigenous reactor, we may start working on it from 2025 onwards. So you may expect this year or maybe next year, another initiative from the government of India can come up. Although when you talk about the various concerns related to nuclear fusion, there is always going to be a risk of nuclear weaponization, right? Risk of nuclear weaponization is always there, and considering the hostility between countries, it can be an even bigger risk, right? Sadly, between India and China, there is hostility. We have seen hostility at the bordering areas. So it is a fact that there will definitely be a concern, right, between either of the countries for the risk of weaponization. Then regional security. I hope this is something that all of you can understand. Whenever any country in the region of Asia, South Asia, Southeast Asia, if any country develops something so significant that has a possibility of being weaponized, it will of course create conditions. It will of course create sentiments that may create insecurity among the smaller nations, right? So this is obviously, this is one thing where you can say there is definitely a call for a balancing agent, right, involved here. Then there is also a fight. There is also a race towards energy leadership. Like I said, nuclear fusion could be a source of sustainable future energy, and if China or any other country develops this technology first, it can obviously be a source of future energy security. So you can understand it is definitely a race to find the next possible source, next possible sustainable source. Now guys, although right now producing electricity from nuclear fusion is a distant dream, because we have been able to sustain it for only 18 minutes. But guys, 18 minutes itself is an achievement. Suppose if we keep expanding at this rate, we keep tripling it, we keep compounding it, then there is definitely a possibility that in the coming decades or two, we may have nuclear fusion reactors ready for converting them into energy. It is also a plan as per many of the initiatives, like ITER itself has got an initiative. It's going to be an extension of ITER where we'll try to demonstrate electricity production from this reaction technology. I hope you understand. And for India in particular, technological gaps are too wide, right? We need more investments in research and development. We need more scientists. We need more and more, contributions, collaborations, so that India can also work in the area of nuclear fusion, right? Although it's not like we are almost layman in this field, but it is just that when China develops something, it becomes a news of consideration in India. All right, guys. So next, let's see the next development here. So next is NGLV. NGLV, popularly known as Next Generation Launch Vehicle. Now, ISRO, we guys are aware that ISRO has been the principal research organization in the area of space for India. Now, their chairman, the newly appointed chairman, Dr. V. Narayanan, he has mentioned in one of the interviews that they have already given approvals for new launch vehicle. Now, guys, when I talk about launch vehicles are basically the rockets that take the space payload, space payload to space. So basically, these are rockets that carry satellites to space, carry humans, or whatever equipments you want to carry, observatories, cameras, telescopes, all these things in space. So we call them the launch vehicles, right? They are the carriers who carry things in space. Now, guys, in India right now, we have three functional launch vehicles right now. We have the famous polar satellite launch vehicles, the PSLV. Then we have the GSLV, which has two variants, GSLV Mark 1, GSLV Mark 2, and the GSLV LVM3, Launch Vehicle Module 3. And we have got a new entry that is called SSLV. It's called Small Satellite Launch Vehicle. PSLV, GSLV, SSLV. I'll repeat, PSLV stands for Polar Satellite Launch Vehicle. GSLV stands for Geosynchronous Satellite Launch Vehicle. And then we have the SSLV, which stands for Small Satellite Launch Vehicle. These are the three launch vehicles that are already, deployed. They are already working, right? But there is an issue, guys. The issue is all the launch vehicles that India right now have, their maximum payload capacity does not go beyond 5,000 kgs to 8,000 kgs. So 5,000 to 8,000 is the maximum payload capacity that India can put right now. And when I say 8,000 kg, I'm talking about the lower Earth orbit, right? The orbit which is nearly 300 kilometers above the Earth's surface. This is where we can touch maximum, 8,000 kgs. Now, guys, 5,000 to 8,000 seems to be a big number when we talk in general. But when you compare it with the other countries, launch vehicles, they are already at the range of 30,000 kgs. In fact, SpaceX Falcon Heavy, which is already a rocket, under service, this rocket can take up to 63,000 kgs. So you can understand that although 8,000 kgs looks good, but it is not good enough, right? And considering the future objectives of India, like India is planning to have its own, even after successful execution of Gaganyaan, where 3 Indians will go in space. They will spend some time in space and come back. After the successful execution of Gaganyaan, we have a future plan of setting up our own space station. We call it the Bharatiya Antariksh Station. It is expected to be ready by 2035. For a space station, our GSLV is not enough. It will not be able to carry enough payload so that we can set up a space station. In fact, beyond space station, you guys know that India is also planning to send its next moon mission, which is going to be a retrieval mission. That means we are going to retrieve some samples of the moon soil, moon surface, and bring them back to Earth. For that, we need an even bigger launch vehicle that can go to moon and come back. For that, we again require bigger launch vehicles. The current GSLV may not be able to deliver. Then, guys, by 2040, we also have a plan of sending humans to moon. So if moon is supposed to be our location where humans would land, just imagine the kind of payload we have to carry. We have to carry a capsule large enough that can carry humans there and then bring them back. I hope you understand. So for such kind of missions, our current launch vehicles are not enough. We have to make launch vehicles bigger, more capable, and in fact more economical, guys. Not just capable, more economical, right? Because we all understand space today is seen as the next economic sector. There are private companies coming up. The private companies, they are competing with us already. So we have to find methods of making space more accessible, affordable, so that new technologies can take over and new entrepreneurs can be generated in this area. I hope you guys can get it. So there is a clear need of new launch vehicles, and this particular NGLV, its first objective is to develop a partially reusable heavy lift launch vehicle. Guys, now this is also an interesting fact about Indian launch vehicles. Our launch vehicles are not reusable. Just to give you a small fact, if when you compare when you compare the missions that ISRO or SpaceX executes every year, ISRO on an average executes nearly 12 to 15 missions, on an average 13 missions every year. SpaceX, on the other hand, execute one mission every 6 days. That means every 6 days their rocket is ready for launch. How is it possible that a company is able to execute their space programs so efficiently? The reason is their rockets are recoverable and reusable rockets. That means when the rocket go up in space, they deploy the payload and come back. They re-enter into the Earth's atmosphere and undergoes a successful touchdown. Now they have made something called Mechazilla, which does not need a touchdown. They can simply hang, they can simply get clamped on the Mechazilla and it is ready for the next launch. So this is something that SpaceX have already achieved. Unfortunately for India, all the launch vehicles that we have in working right now, none of them are recoverable or reusable launch vehicles. So every time when we go for a next launch, we have to make a launch vehicle from scratch. So this is what also needs to be eliminated, and the next generation of launch vehicles that India is planning, it has to be recoverable, reusable. So currently, as per the news reports, we are planning to make a partially reusable launch vehicle, which is going to have a much bigger payload capacity, not just 8,000 kgs, and it is expected to be ready by 2035, way before the Bharatiya Antariksh Station would set up, right? And it is expected to support all future missions of ISRO. And like I already mentioned, we have plans for sending humans to moon. We have a plan for setting up, a space station. Or for all these things, we need the heavy lift-off next generation launch vehicle. Now, what are going to be its salient features? So it is going to be a reusable launch vehicle. So it would be recoverable and reusable. That means once you make this launch vehicle, the launch vehicle will not disintegrate. It will maintain its integrity, enter back into the Earth's atmosphere, and then it's going to be ready for the next launch. This is the one big advantage that we'll have, because now we can shorten the time period between every two missions. Secondly, it is going to be bigger and more powerful. Just to give you a hint, it is expected, because these are only sourced from news reports right now, it is expected to have a payload capacity of 30,000 kgs. This is expected to be the payload capacity. That means nearly 6 times more than the current payload capacity, 30,000 kgs. And guys, its own weight is going to be somewhere around 1,000 tons. 1,000 tons is going to be the weight of the launch vehicle. That means its own weight is going to be 1,000 kgs, 1,000 tons, and alongside with this 1,000 tons, it will be carrying 30 tons of payload. So 30 tons of payload, this is going to be the payload, right? And 1,000 tons is going to be its gross weight, right? Its gross weight is going to be 1,000 tons. And guys, its height is expected to be 91 meters, right? Currently, the PSLV is having a height of nearly 44 meters, right? So you can take a hint. It is going to be nearly double the size of PSLV. I hope you guys can understand. It will be capable of carrying out multiple missions. Multiple missions means it can carry out missions for placing satellites. It can carry out missions for human space flight. It can also carry out missions for lunar or interplanetary missions, right? And it should also be able to carry out observatories in space. All these kind of missions, one single rocket should be able to deliver. I hope you guys can understand. So this is going to be a very capable rocket. And lastly, guys, there is already a third launch pad Launch pad is basically the place from where the launching takes place, assembly and the launching takes place. So it is going to be there's already a third launch pad being developed, being established at Sriharikota, from where we launch our satellites. We have the Satish Dhawan space station located there. So the third launch pad is already there. It is already under construction right now. The cabinet has already approved the budget for it. So we are already in the direction of working out in making our next generation launch vehicle, right? Already there are two launch pads, one for PSLV and the other one for GSLV, and the third launch pad is already being developed, right? So you can understand, as we are working on the third launch pad, the blueprint of the next generation launch vehicle might already be ready. I hope you guys are able to get it. This is what we have under NGLV. Now the third news that was there, it is related to forever chemicals. Now, before I talk about this, let me tell you what exactly are forever chemicals. So guys, as the name suggests, forever chemicals are basically pollutants. They are basically very dangerous pollutants, can cause cardiovascular problems, carcinogenic means cancer causing. So forever chemicals are technically pollutants that are persistently found, right? That are persistently found. Once they are produced, they remain persistent in our ecosystem, in our environment. And these chemicals, they can cause serious illnesses. They can cause serious health implications. They have a serious health impact. They can be carcinogenic, cancer causing. They can cause cardiovascular problems, right? They can cause cardiovascular problem. And guys, some of these, in some cases, they have also been found to affect infants or children, right, more severely. Example of this forever chemical is PFAS. PFAS is a popular forever chemical. And many of you who have been following news, you might have got the hint. PFAS was there in news related to this recent controversy where Apple Watch straps, the straps of the Apple Watch, they were found with plastic, with silicone strap which had plastics, a little bit of plastic, and that plastic had PFAS, right? So there was a recent controversy where Apple Watch was found to have PFAS in their straps, and you guys can understand that is the entire context behind this particular news, right? So PFAS, it stands for polyfluoroalkyl substances. PFAS, polyfluoroalkyl substances. We often call it perfluoroalkyl substances, right? Perfluoroalkyl substance or polyfluoroalkyl substances. These are called PFAS. These are the kind of chemicals that are often used in non-stick cookware. You guys must have heard there are a lot of reports on and off where people suggest not to use the traditional non-stick cookware, especially if the non-stick coating is being withered, has been scratched immensely, or there are cracks developed in the non-stick coating. Prefer not to use it anywhere, right? It is going to be a severe or serious health hazard. It is used in non-stick cookware. It is used in water repellent clothing. So those clothing which are developed for water sports, they happen to repel in some water, so they often put a little coating of PFAS on it, right? Then it is used in strain resilient fabrics, and it can also be used in firefighting foams, right? All of them have one function, that we have to somewhat repel water or different kinds of liquid formation, right? They are quite persistent in nature, so once they are produced, there is no way of eliminating them from nature. There is no substance that use PFAS as their resource, as their food. So there is once produced, it will remain there. It is a non-biodegradable substance. And you guys can understand, if it is non-biodegradable, there is definitely a lot of environmental impact and health concerns. I've already told you, many they have been declared as carcinogenic. Cardiovascular problems can be originate or can be sourced to them. Now, what is the recent research on PFAS? Basically, there is a research that has claimed that polar bear fur, the fur of the polar bear, contains a unique oily substance called sebum. Now remember guys, this sebum is found in mammalian organisms. Humans also have something called sebaceous glands. Sebaceous glands are basically those glands that secrete, they are oil glands. They are oil glands which are found on the skin. So you must have heard some people say that they have an oily skin. Basically, wherever they feel a little oily substance being released, it's basically the location of the sebaceous glands of their body, right? We normally have them on our face, right? So sebaceous glands are the ones that secretes this particular oil called sebum. Now, for humans, sebum do play an important role for our skin also, but in the case of polar bear, this sebum, this oil that is secreted from the sebaceous gland, it has a unique property of preventing the polar bear skin to touch ice. It is a way how polar bear, it's a way how polar bear maintains, ice from sticking to its fur, right? So the fur, whatever polar bear has, this sebum that is going to create a layer on the fur. Why the polar bear's fur does not stick, ice doesn't stick on the polar bear fur, is mainly because of this sebum. Now this sebum is a organically, biologically produced chemical on the skin of the polar bear, and this is mostly made up of cholesterol and diacylglycerol and some fatty acids. Diacylglycerol, cholesterol and some fatty acids, these three chemicals together are the ones that create sebum. Now guys, just use your common sense. If sebum on the fur of the polar bear is not allowing ice to stick on the fur, can we use the same sebum to produce non-stick cookware of the next generation? Can we use it to produce all those things where PFAS is being used? PFAS is an inorganic, sorry, it's an organic, but it's a persistent chemical. It is a dangerous pollutant, but sebum, our body also naturally produces it. Of course, their sebum is different, but that sebum effectively can help in reducing the harmful impacts of PFAS wherever it is used. So guys, there is a technique called biomimicry. Biomimicry is basically, it's a technique of innovating new products by mimicking natural products. So biomimicry is a very popular technique where we try to mimic natural phenomena and create innovations of human benefit. So if we can create the next generation of cookware, the next generation of clothing, water repellent clothing, the next generation of stain resilient clothes, water repellent clothes through sebum rather than PFAS, then this generation of clothing is going to have no harmful effect on nature, no harmful effect on humans, and it's going to be completely biodegradable. So one can easily understand why this news is so important. Now you can expect a question on this directly from PFAS. You can expect a question on PFAS, and you can also expect that the UPSC can write a statement that there are bio alternatives available for PFAS which can be extensively used to replace PFAS. I hope you guys can understand. This is already a controversy internationally after this Apple Watch episode. This can be a relevant question in UPSC exam also. I hope all of you guys have been able to get it. Now let's move to the next topic of our discussion. So next is INSV Tarini. INSV stands for Indian Naval Sailing Vessel. It means it is not an armed vessel. It is not a ship that is meant for combat. It is a ship that sails. Sailing is basically where we have those, sailing cloth where the wind pushes the ship, right? You must have seen Pirates of Caribbean and such. Those were all sailing ships. So this is our INS Tarini. It's a sailing ship and Indian naval sailing vessel. Now this has been in news because of its second expedition that it has started. It is called Navika Sagar Parikrama. Navika Sagar Parikrama 2. It is the second expedition of its type. First expedition of INS Tarini has already been successfully executed, where INS Tarini left from India and circumnavigated the entire globe. It traveled over the entire globe and came back. INS Tarini has already achieved this. Now a second parikrama, a second full circumnavigation of the earth has already is going on. It's called Navika Sagar Parikrama 2. Remember this word. This can be asked in the UPSC exam in the exact same manner. What is Navika Sagar Parikrama 2 expedition related to? So remember, it is the second expedition of INSV Tarini of covering over 40,000 kilometers, right? And test the resilience and capabilities of INSV Tarini and its crew members. I hope all of you get it, right? Now, the objective is simple: to circumnavigate the entire globe. So this is what is the INSV Tarini doing right now under the Navika Sagar Parikrama 2 mission. Got it? Now, why it was in news? So guys, recently INSV Tarini has crossed over a location in the Pacific Ocean, in the South Pacific Ocean, called the Point Nemo. Now, before I talk about Point Nemo, let me cover some important features about this Navika Sagar Parikrama 2 mission. It is a mission headed by Lieutenant Commander Dilna K and Lieutenant Commander Rupa A. Interestingly, guys, both of them are women commanders of the Indian Navy. So this particular mission is completely headed by women, right? Women officers of Indian Navy, right? Although we should call simply officers of Indian Navy, but it is always a pride when you refer women officers, right? So they have recently achieved a remarkable milestone by crossing the Point Nemo. Now, what is so special about Point Nemo? Point Nemo in the Pacific Ocean is treated as the most isolated point on Earth. It is the most remote location on Earth. In fact, it is such an interesting point. This is where it is the closest land to Point Nemo is around 2600 kilometers. You can see it is 1666 miles. This is the closest landmass from Point Nemo. It is around 2600 kilometers. This is the closest landmass. In fact, it is often said that the closest person to Point Nemo is an astronaut in space, which is around low Earth orbit, which is around 300 to 500 kilometers in altitude. So the closest person to Point Nemo is an astronaut. Now, guys, this Point Nemo has been very popular, not in terms of, in terms of navigation, but in terms of satellite deployment or satellite disposal. This Point Nemo is famously called as the graveyard of satellites. So whenever all these satellites that we have been launching for the past 50-60 years, especially NASA and USSR has been launching it, NASA and Russia has been launching it multiple times. These satellites, when they run out of their life, when they complete their life, they are mostly dragged down and disposed at a certain location in the Pacific Ocean, and that location is Point Nemo. This Point Nemo has already, engulfed major missions like one very popular space station of Russia, Mir. When it completed its service life, it was dragged back into the Earth's atmosphere and died and took its last dive at the Point Nemo. So Point Nemo is a popular location in South Pacific, and this location is considered as the graveyard of satellites. Now, what INSV Tarini has done here, they have collected water samples in this region, and by collecting the water samples, they will give us valuable insight about the oceanic conditions and the marine biodiversity in that region. And we can also understand, if these satellites are dumped at the Point Nemo, what is going to be the impact of such dumping on the marine life. You guys remember, space debris is a problem, and we are trying to find a solution to bring back the space debris somehow. In fact, India has also performed a similar test. Last year, or maybe last to last year, India performed a recovery of the RESAT satellite, which was launched almost 10-12 years back. And once it completed its service life, we brought it back, and it successfully underwent a touchdown at the Bay of Bengal, and we retrieved it from there. So this is obviously a possibility of bringing back the space debris in this way. So by this particular mission can help us giving some insights about how the marine biodiversity of a region gets affected when they are constantly encountered by satellites and satellite based materials. I hope all of you get it. This was the reason why INSV Tarini was in news. Now, guys, moving ahead from there, remember Point Nemo, guys. UPSC can ask a straightforward question on Point Nemo itself, right? Now, guys, the next news here is the US FDA, the US Food and Drug Administration, has recently approved a non-opioid painkiller. Now, guys, mostly the painkillers that we have, morphine, codeine, these are the popular painkillers. They are mostly made from opium. I hope all of you know opium is a narcotic drug, and it's a crop from where a lot of narcotic drugs are made. The entire crop produces some of the other narcotic drugs, and which are definitely very addictive, right? They are addictive, and their black marketing involves a lot of crimes also, right? So US FDA has been able to successfully undertake a research for almost 2 decades, almost 20 years long research. And after this 20-year long research, US FDA has finally approved a first of its kind non-opioid painkiller. That means it's a painkiller that is not derived from opium or does not contain the addictive chemicals like opium. I hope you guys are able to get it. Now this is basically something that has happened for the first time. So you can see this particular news cut here. Opioids are those class of drugs that are derived or mimic natural substances found in the opium poppy, right? So this is what chemicals like morphine, codeine, heroin, fentanyl, oxycodone, all these are the chemicals that are basically found in the opioids. By creating a non-opioid painkiller, we have paved way for new generation of medication that is equally safe as that of other conventional medicines, but do not have any addictive properties. So this can be a game changer in the world of medicine. So the non-opioid painkiller, this is the name. I can't pronounce the actual name for it, right? So you guys do write it in your notebook, and it is mostly sold under the brand called Jornavax, right? So Jornavax, right? Likewise. So this is what is the name of the painkiller, and what are going to be the important points. You guys can easily take a hint. First of all, it is non-addictive. Secondly, it has been found to be effective in treating both moderate to severe acute pain. So for all kinds of painkillers, it can be a good substitute. Then guys, its safety profile is found comparable to the existing pain medications, right? So whatever the existing pain medications are, we have been able to find that they are equally safe and equally potent, right? And the benefit is it does not have the risk of creating any addiction. Guys, but there is one issue, that it is a patented drug. So right now it has been priced higher than the generic drugs, but it is obviously a safer alternative. So that becomes the USP here, right? Right now in India, there is no such discussions going on in terms of compulsory licensing, in terms of the patents. Although US FDA has approved it right now, it has not been made available in India. But now you understand, if UPSC would want to ask a question, it can simply ask about opioids and non-opioid drugs. That can easily be asked. I don't expect UPSC would ask the name of the drug per se, but opioids and non-opioid drugs can easily be asked in the UPSC exam. I hope all of you guys have been able to understand. This is what we have under this. In this week we had a lot of news, but the news is mostly factual. Except the nuclear fusion reactor, most of the other news is factual. So I expect you guys to simply keep noting down the facts. They become very handy, guys, and many of this news we may even get a chance to discuss in the future lectures as well, right? So please keep a note of all these things, right? Now comes the topic of building blocks of life found in the samples of asteroid Bennu. Now let me first talk about what is this asteroid Bennu, and then we'll talk about what has been the recent developments of asteroid Bennu. Now guys, when you talk about Earth, I hope all of you guys know what is an asteroid. Asteroids are basically rocks. You guys can easily understand, asteroids are normally found in the so-called asteroid belt. So if this is the Sun, this is the Earth, this is Mars, and this is Jupiter. Between Mars and Jupiter, we have something called the asteroid belt. Between Mars and Jupiter, we have something called the asteroid belt, right? I hope this is something all of you must be knowing. Asteroid belt, right? So asteroid belt is that belt where all these asteroids, they revolve around the Sun, right? This is the asteroid belt. But guys, some of these asteroids, they do not carry this trajectory. Some asteroids, what they do, so suppose this is the asteroid belt, and let's say this is the orbit of Earth. This is the orbit of planet Earth, right? Ye Earth ka orbit hai. So guys, what happens in some asteroids, what they do, instead of taking their own path, their path somewhat get distorted, and sometimes it runs very close to Earth. It comes significantly closer to Earth, as you guys can notice here. These asteroids, who sometimes or partially in their journey comes close to Earth, we call such asteroids as Apollo class or Apollo group of asteroids. Or we often call them as near Earth asteroids. We also call them as near Earth asteroids. We have a separate name for them. We call them Apollo class or Apollo group of asteroids, right? Now guys, Bennu is right now the largest Apollo asteroid. It is the largest Apollo asteroid in this remark, guys. Guys, I hope you understand. When dinosaurs died, the most convincing theory says that dinosaurs died because of an asteroid attack. That asteroid must have been an Apollo class asteroid only, guys. I hope you understand. Otherwise, asteroids are not going to come close to Earth. But there are certain asteroids that sometimes come dangerously close to Earth. And this asteroid would have hit Earth during the time of dinosaurs, and that caused the complete extinction of dinosaurs. I hope all of you understand, right? So so under the Apollo category, Bennu is right now the largest of out all the asteroids. It is approximately 500 meters in size, guys. 500 meters ke aspas hai, right? I hope you guys are able to understand. And guys, why it has been in news? There is a recent study from a university in Korea which has been tracking the movement of Bennu with all the data that they could collect, and they have predicted that Bennu may hit Earth by 2182. Guys, earlier there was another research that claimed Bennu may hit Earth by 2135. It will come dangerously close to Earth by 2135, but now the new research says by 2182. Of course, 2182 is too far from here, and there is a high chance that it may not cause a similar kind of damage what we saw during the time of dinosaurs. But yes, if Bennu hits Earth, then it can trigger an extinction level event, because a 500 meters large asteroid, if it hits Earth, there is a high chance that this asteroid is not going to burn out completely. So when it hits Earth, it will be a collision equal to 8 to 10,000 nuclear bombs. And that collision will be significant enough in changing everything on Earth. It will change the life forms, plants, animals. It will create a massive cloud of dust. It will take another 100 years for that cloud of dust to settle. So a lot of impact would happen. But this is going to happen by 2182, right? So we can't, so I don't think UPSC would be inclined to ask this particular question as of now, that what will be the impact if an asteroid hits Earth. Everything that has happened during the extinction of dinosaurs is what an impact you can expect. But what other research have found that Bennu contains something really fascinating. Now guys, let me tell you something about Bennu and what is our research on Bennu so far. So guys, what happens? NASA of US, they launched one mission called OSIRIS-REx. There's a mission called OSIRIS-REx. It was launched under the New Frontier program of NASA. New Frontier program of NASA was started in 2006, and in 2014 OSIRIS-REx was launched from Earth. And this particular probe, its objective was to reach Bennu, take its photographs, land on Bennu, collect a sample and come back. So its objective was not just to go and study Bennu, but collect a sample of Bennu and bring it back to Earth. Got it? So if I tell you the full form of OSIRIS-REx, you should be able to visualize what should be the objective of OSIRIS-REx. Like the full form is origins. It will study the origin of the solar system. Spectral interpretation. It will take images of Bennu in various spectrum, various types of, solar spectrum, radio waves, infrared, right, visible light, and study all those spectral images in various spectrum. Images in various spectrum helps us to identify its temperature, its chemical composition, its topography, its interior composition, all those things, whether it is a uniform stone, all those things, right? Spectral interpretation. Resource identification. We can identify if there is any resources found there. And last is security, right? Regolith explorer. Regolith means we will go deep. Regolith is basically the soil that is available above the bedrock. So we'll drill into the bedrock of Bennu, collect that sample and bring it back. A regolith explorer. I hope you understand. I'll repeat. It is origins, spectral interpretation, resource identification, security, regolith explorer. So all these are technically the full form and also the objective of the OSIRIS-REx initiative. Now this OSIRIS-REx probe, it brought the sample of Bennu. The sample of Bennu was brought back to Earth in September 2023. In September 2023, sample of this OSIRIS-REx was brought back. The sample was not big enough that they could take this sample and distribute it all across the planet. They took only 10 grams of that sample. The overall sample is nearly 50 grams. So they got this almost 50 grams of the sample. They took 10 grams out of it and they kept the rest of the sample completely preserved in liquid nitrogen medium for future technologies, for future generations. So in future, if new technologies emerge of diagnosing a sample, studying a sample, NASA has simply kept it for the future generations. Now the advantage of such sample is, see, you guys understand that a lot of asteroids keeps falling back into Earth, right? Asteroids girte rehte hain. We call them meteorites, right? Those rocks from space, they keep falling, and we keep collecting the samples of the meteorites. Also, we keep studying them. But the problem is when the meteorite is falling under the Earth's atmosphere, because of the heat of the Earth's atmosphere, the atmospheric friction, its chemical composition or its structural composition changes. Its structure changes. Because of oxygen in the air, a lot of chemicals gets oxidized, right? So chemical composition changes, structural composition changes. In fact, sometimes we also see traces of bacteria, fungus, because it collects from the Earth, and their enzymes, bacteria and fungal enzymes, may also leave some residue which may change the overall true nature of an asteroid. So collecting a sample of an asteroid which has not yet entered close to Earth, which has not yet reached close to Earth, the samples are completely preserved, and those preserved samples, when you study them, you can really understand what this asteroid is truly made up of. How this asteroid would have impacted Earth if it would have collided. All these realities can be known only when the sample is completely safe from any external exposure. And that is the advantage of Bennu, of this OSIRIS-REx mission. So guys, the recent findings have been really interesting about Bennu. Scientists have discovered that Bennu has 14 of the 20 amino acids. The chemicals of 14 of the 20, see, if you know about amino acids, there are total 20 types of amino acids that the human body or any organism on Earth requires, right? All these 20 amino acids are responsible for creating all the proteins in our body. Out of these 20 amino acids, 14 of them, guys, are found. There is presence of ammonia. There is presence of formaldehyde. All these are organic compounds, and when they react with each other, they produce even more complex organic compounds. 14 out of 20 amino acids are found on Bennu. Secondly, even more interesting, they also have the nucleobases of DNA and RNA. Guys, when you talk about DNA and RNA, which is the main building block of life, when you look at DNA, DNA is actually made up of, or DNA, RNA, both of them are made up of sugars plus phosphorus, or you can say phosphate group. I'll write down phosphorus plus nitrogenous bases. Nitrogenous bases, right? Nitrogenous bases. There are 4 types of nitrogenous bases in DNA. DNA have 4 types of nitrogenous bases. We call it adenine, thymine, adenine, thymine, cytosine, and guanine. These are the 4 nitrogenous bases that are found in DNA that makes up all the DNA of our body. Secondly, when you look at RNA, RNA also have the same adenine. It also have the same cytosine, same guanine, but in place of thymine, it has got uracil. So if you count, there are 4 nitrogenous bases of DNA and 1 nitrogen base of RNA, that's uracil. All 4 and 1, 5 of them are found on Bennu. Now guys, Can there be anything more fascinating than this? That means this asteroid, who does not support life, which has been created during the origin of the solar system, already contains the nucleobases of, that means they contains the nucleus of all those bases. It contains the similar kinds of atoms which are needed for the DNA and RNA. I hope you guys are able to understand. This is a very interesting discovery. And guys, not just this, it also contains evaporated brine. What is brine, guys? Brine is nothing but a composition of lot of different mineral salts. So it contains sylvites. Sylvites is potassium chloride, KCl. Trona is basically sodium carbonate, sodium bicarbonate. Together it's called trona. Calcite is calcium carbonate. Halite is bromine, right? Chlorine, bromine, and such. So we have found mineral deposits of potassium chloride, mineral deposits of sodium carbonate, sodium bicarbonate, that means sodium and carbon, calcium and carbon, bromine and calcium, bromine and fluorine, bromine and chlorine, sorry. So all these have been found. That means there is no water is not there, but we have got deposits of these chemicals or deposits of these minerals which are found in the salt water on Earth. That means one thing could be inferred, that in the origin of the planet Earth, these asteroids that would have attacked, they might have given all these minerals. They would have been sourced from such asteroids, which are now found in abundance in our oceans. And guys, another interesting fact is similar foundings have been found previously in two of the celestial bodies. One is Cirrus. Cirrus is another asteroid, but it has got a status of a dwarf planet. It is found in the asteroid belt. Vesta, Cirrus, they are found in the asteroid belt, but it is a dwarf planet. And second is Enceladus. Enceladus is one of the moons of Jupiter. One of the moons of Jupiter, even that have been found to have similar brine solutions, similar brine deposits, right? But Enceladus has a thick layer of ice. Under the ice, we have been able to discover this similar brine deposits. So I hope you guys can understand this particular discovery of these essential chemicals on Bennu can be a landmark study, and it can help us to understand the origin of the solar system. And it clearly shows that these chemicals that are important for life, they are already there in asteroids. So one can easily understand what makes our planet Earth unique and, you know, blessed with life. These asteroids can help us learn that. I hope all of you guys can understand. Now UPSC can ask anything on Bennu. There is a massive opportunity of different questions possible here. UPSC can ask questions related to what is Asteroid Bennu, Apollo class asteroids, what is OSIRIS-REx, what is the recent findings, all these things. So I expect you guys to read holistically about Bennu, holistically about OSIRIS-REx. In our classes, we extensively talk about OSIRIS-REx and Bennu. I hope this discussion would be able to help you out further develop some understanding of this asteroid. Then guys, next is small modular reactors, or the small nuclear reactors that have been there. Even in the recent discussions in the classes, I've been talking about small modular reactors. So let's talk about them quickly. So guys, in the recent union budget of 2025, there have been one key initiative. That is to develop 100 gigawatts of nuclear energy capacity by 2050, by 2047. By 2047, when India celebrates 100 years of its independence, we would have 100 gigawatts of nuclear power capacity. That is one of the objectives of the Union Budget 2025. Now, what is a small modular reactor? So guys, small modular reactors are basically nuclear reactors only. They are nuclear reactors, right? They are nuclear reactors, and this nuclear reactor normally have a power generation capacity of less than 250 megawatts. So they are having less than 250 megawatts of power generation capacity, right? Their power generation capacity is less than 250 megawatts. And guys, these small modular reactor, they are easy to assemble. Like it says modular reactor. Modular means you simply have to assemble it. So they can be built in small components. So medium, small and micro, small and medium enterprises can also manufacture them, and you can simply assemble them at one single location. So we call them modular reactors. So they are easy to assemble. They are easy to assemble, right? So you can understand there's a lot of opportunity for India in this. When they are easy to assemble, that means there's a huge opportunity for micro, small and medium enterprises to work. And on top of that, because they are small, it does not require a large area. You can build them in smaller towns in creating a more decentralized power generation system of the country, right? So this is what we have under small modular reactors. According to the current nuclear energy mission, so the Union Budget of 2025 have envisaged a nuclear energy mission for which they have even allocated 20,000 crores funding, and their objective is to set up 5 SMRs and make them operational by 2033. 5 SMRs or 5 small modular reactors should be set up and they should be made operational by 2033, right? And because the budget is 20,000 crores, there is also some more hints that the budget has given. That is, there would be definitely some involvement of private sector now. So right now, nuclear energy was a reserve subject. No private intervention was allowed. But now the budget has given some hints that we may require or we may invite private bidders even in nuclear energy. Guys, this is going to be very interesting because there are 2 laws that I should talk about here. One is the Civil Liabilities for Nuclear Damages Act 2010. Civil Liabilities for Nuclear Damages Act 2010. And we also have something called Atomic Energy Act, which is the principal act. Atomic Energy Act of 1962, right? Atomic Energy Act of 1962. So guys, Atomic Energy Act of 1962 talks about nuclear waste management, nuclear waste disposal and such things. Whereas Civil Liabilities for Nuclear Damages Act talks about public liabilities at the time of nuclear disasters. Public liabilities at the time of nuclear disasters. Suppose if a nuclear disaster happens, God forbidden, if a nuclear disaster similar to Bhopal gas tragedy, which has affected and killed so many people around, if a disaster like that happens in a nuclear power plant, which will be even more grave and more devastating, because the nuclear power plant is not going to just release energy, but will also release radiation that could be causing long-term impacts. All of you guys are aware about Chernobyl nuclear disaster, Fukushima nuclear disaster. So guys, this law talks about public liabilities. As per the current law, which was passed in the year 2012, although the law was introduced in the parliament in 2010, as per the current law, the liability for any nuclear disaster was with the suppliers of nuclear equipments, reactors and such. And because in India, most nuclear power plants are built by foreign companies, Russia, USA is also working on one of them, Japan is working on one of them, then Canada has given us a lot of nuclear reactors. Because most of the nuclear power plants that we have, they are built by foreign suppliers. This particular law, when introduced in 2012, it was something that was not well received by foreign suppliers, right? And there were a lot of negotiations going on to somewhat, make this law somewhat reasonable. Because how can a supplier be held responsible if the operations of the nuclear power plant has already been transferred to somebody else? So now there is an indication that the Civil Liabilities for Nuclear Damages Act is going to be amended. And once amended, the liabilities may be shared not just with the supplier but also with the operator. Operator's name would also be there. Mostly the operators of nuclear power plants in India is Nuclear Power Corporation of India Limited. It's a public sector undertaking. So one can easily understand that there are some legal changes coming up which may open up a window of opportunity for new private players to participate, and also foreign collaborations can again be re-established so that the liabilities, which was an issue that foreign organizations had earlier, this long-standing issue can be resolved. I hope all of you guys can understand this. So there is a chance of new involvement of private sector, and there is also a possibility of new involvements of foreign entities. So these are the recent developments in SMR right now. I hope all of you understand. Now here, one more point I should tell you, that once these laws are amended, of course it will clear the deadlock of the past almost a decade, but you can understand that it will also pave way for Indian startups to emerge in the area of nuclear energy. So guys, whenever you're writing an answer for nuclear energy, because this could be a question that I can see it could be a good question in the mains exam also, regarding SMR, their status, and the overall status of nuclear energy in India. This can be a good question, and you can definitely mention that when they are opening a windows for private sector, it's not only that large scale industries can come. Although we have seen, we have been hearing news that Tata Power is already working for it. They are simply waiting for the amendment to come. But there can be a lot of opportunities in which small sector organization can also participate, because being a modular reactor, you don't have to set up every component in a single facility. You can manufacture it in different facilities and then assemble it together. So that makes SMR a very good initiative. And considering India, where small towns are located at different places, we can decentralize the power generation capacities, and SMR could be a good solution in that direction. In fact, guys, Russia has a floating nuclear reactor. I have talked about this floating nuclear reactor as one of my previous focus weekly. That can also be a good opportunity where we can mount a small modular reactor on a ship and put it all along the coastline and generate nuclear energy for the coastal areas without putting any burden on the Western Ghats, especially on the western coast, which is already vulnerable, guys. A biodiversity reserve, a biodiversity hotspot, and that is already vulnerable. I hope you understand. In fact, guys, Rosatom of Russia, it is already have showcased interest in helping India transferring the technology of small modular reactors and jointly developing small modular reactors with India. I hope all of you guys can understand. This has been the development in the area of SMR. But remember, understand this, that we will again be talking about SMR as and when the amendments to the Civil Liabilities for Nuclear Damages Act comes up, or the Atomic Energy Act comes up. I hope all of you guys are able to get it. This is what we have under SMR. Now guys, next is AI driven genetic testing. Now, artificial intelligence is one such technology which is basically affecting all sectors of life. Now, although it demands a separate discussion altogether, I am planning to make a separate video on AI and its development in India, its progress in India, its status in India. Especially after this DeepSeek application of China, it is even more important to come up with a separate video like that. I will definitely come up with a video of that nature. But let's talk about what is this particular AI driven genetic testing we are talking about. So guys, there has been another key initiative in the Union Budget of 2025 related to AI based genetic testing. Now guys, the budget has already envisaged to enhance genetic testing and precision medicine in India. So guys, all of us understand that there was already a news which I covered about Genome India project, where we have successfully identified 100 different population diversities of India and identified their genomes. Now the objective of identifying the genomes of 100 different populations is that we can learn about precisely learn about different diversities of genetics. It can help us to create personalized medicines, more precision medicines, and also learn how the Indian diversity is vulnerable to various diseases. We can also use the same data to help other countries also to devise their own health strategies, right? It can eventually help in finding lineages, legacy, movement or migration, all those things, right? When we compare it with the global database. Now, the Union Budget has talked about using artificial intelligence for further expand genetic testing and precision medicine. In fact, India is seen as to revolutionize the global genetic testing market also by making cheap tools for AI based genetic testing. There is in fact a startup called GeneBox, which is already leveraging AI to process vast amount of data, genetic data, and trying to use AI driven algorithms to help predict genetic predispositions and provide personalized recommendations based on individual genetic profile. So there is a huge opportunity of using artificial intelligence in creating next generation medications by genetic mapping, genetic testing. I hope you guys can understand this. Now, but there are some challenges, and the challenges seems to be same for almost every AI driven technology. The first challenge is privacy and data security. One can easily understand, without your consent, without the permission of the individual, all of your data of your genetic data may be shared with others. That also creates an ethical dilemma. A consent for every genetic data, can there be a consent, a pre-consent taken from every individual to use the to use their genetic data? To what extent the genetic data can be used, for in which all application it may be used, all these things creates an ethical dilemma. Then guys, every AI faces one problem, that is the problem of algorithm bias, because AI is trained through data. If the data itself is biased, the outcomes of the AI research are always going to be biased. So how much data we provide and how much diverse data we provide will decide the accuracy of the research. So it is obviously going to be one challenge, how far we can rely on the outcomes of such a research, where the data is 100% guaranteed it is containing all kinds of diversities. Then guys, there is a complexity of genetic predictions also. All of you understand, all our characters are not all genetic driven. Many of our characters are also shaped by our nearby environment, air, water, soil, your food, your diet, your lifestyle. They also play a lot of roles in your day to day or in your characters. Nature versus nurture. So nature is something that nurture is something that you earn genetically, but nature is something that is nature is something that you earn genetically. Nurture is what you get in your lifetime. So your other factors are also predicting a lot of your behaviors, a lot of your diseases. There is and then uncertain genetic diagnostic values. Even the diagnostic standards are not same, right? Diagnostic standards may be different. And lastly, accessibility issues. This research, will it be equally accessible, affordable for every individual in the society? That is again a concern. So these are the challenges which are in general challenges of AI driven genetic testing, right? Of course, again we can expect more topics, more questions, more discussions on this area, because these challenges remains standardized challenges for all AI driven studies. I hope all of you understand. One thing I should tell you, if UPSC would want to ask a question, they can ask. I can right now assume that there could be a mains based question, a question that is more relatable to mains like examinations, and in such kind of questions you can expect things related directly to the challenges, the objectives and such. I hope all of you guys are able to get it. These are the challenges in this particular AI driven testing research. Of course, we will be talking about them again in future as and when new developments come. Now guys, we have another development from DRDO. Almost every week there is one missile testing that I discuss, and this time there has been 3 successful flight tests of a very short range air defense system. In short form, it is written as VSHORADS. It's called Very Short Range Air Defense System, and India has successfully tested, DRDO has successfully tested 3 successful flight tests, and it has registered another feather in the hat of DRDO. And now let us see what we have done in this. So guys, this particular very short range air defense system, it is basically a 4th generation manpad. Now what is it? Let me first show you some of its features. So it's basically a small missile system that is 20 kgs in weight. It carries a warhead, whatever explosive it carries, that is approximately 2 kilograms in weight. It is powered with a solid propellant, so solid fuel propellant is added, and then it can operate up to a distance of 250 meters, right? 250 meters or kilometers. That is the operational range. 250 meters to 6 kilometers is the operational range where it can target anything. It can achieve a flight of up to 3,500 meters or approximately 11,000 feet. And it can fly at a speed of 1.5 Mach. 1.5 Mach means 1.5 times of the speed of sound. 1.5 times faster than the speed of sound. That's the speed which it can touch. And then it is basically guided by an infrared imaging. That means it follows the heat signals of the target, and it will follow the target through its heat signals. And one thing great about it can be launched by shoulder launched. That's what I meant by man portable air defense system, manpad. So guys, what is it? It is a 4th generation manpad. Manpad means man portable air defense. So it is meant to target air defense. That means it is meant to target air targets. Air targets could be a missile system. It can meant to target a missile, or it can meant to target aircrafts, right? Aircrafts. Okay. And this particular system is man portable. That means the soldier is supposed to carry it on his own shoulders and target the aircraft in the sky and shoot. There is already a man portable system available in the Indian Army. It is called IGLA. IGLA happens to be a Russian manpad. It is a Russian manpad, but it has now become obsolete. It is now an older, generation man portable air defense system. Our very own this a very short range air defense system is going to replace the IGLA manpad, right? Now, what makes this particular manpad unique? It has been able to target high speed targets which were flying at a very low altitude first. So we took some targets, mostly drones, and they simulated low flying drones. It simulated low flying objects, and we were able to successfully target it with these manpads. And secondly, the great advantage is that they are indigenously developed. The IGLA was Russian. This one is indigenously developed by a research center called Imarat and in collaboration with the laboratories of DRDO. And the advantage here is that this has shown pinpoint accuracy. Pinpoint accuracy has been delivered. That means they show a very high accuracy, and its operational use is possible in all the three wings: Army, Air Force, and the Indian Navy. All three of them will be able to use the very short range air defense manpads. I hope you guys can understand. And the greatest thing about it, that it can be launched by a simple tripod stand, a tripod launcher, or even a shoulder launched. It can be achieved. So both the testing were done, and we have been able to test them successfully here, right? We haven't come across with an official name for these missiles. So right now we call them the very short range air defense manpads, right? I hope all of you guys are able to get it. Now moving on to the next topic. This is the last topic of the discussion. It is about the dengue early warning system. The dengue early warning system, it has been in the news in the past 2-3 months. It is basically a system that has been developed. It's a AI machine learning driven system developed by IITM Pune, right? So what is it? As we go through this, I'll be able to explain this in alongside with this discussion. So the dengue early warning system, it has been developed by Indian Institute of Tropical Meteorology, IITM Pune. And it is a system that helps us to predict and manage dengue outbreaks. We guys are already aware that in the garb of climate change, mosquito breeding conditions are getting even more expansive. We are constantly seeing even more greater expansions of mosquito breeding conditions. Mosquito breeding diseases, not just dengue, but other mosquito borne diseases are also getting popular. They are getting even more widespread. In Delhi, there was news of dengue outbreak even in the month of December last year, in the early week of December. So one can easily understand that mosquito-borne diseases are on the rise. So IITM Pune has come up with an innovative solution of predicting mosquito-borne diseases like dengue. And for that, what they do, they basically analyze climate factors like temperature, rainfall, humidity, which obviously shapes the dengue breeding season. And based on the temperature, humidity, and rainfall, they have used machine learning and AI to predict a model that can help us with 2 months advance predictions of dengue outbreak. And guys, the news was already in the month of January, already in the month of February, a news has come that moderate rainfall spread over entire duration of the summer's monsoon season led to the increase in dengue deaths in Pune compared with heavy or extreme rainfall. So it has already predicted, a dengue outbreak 2 months in advance, right? So when it comes to this model, they have found that moderate rain, when there is a moderate rain, the risk of dengue is higher. And when there is heavy rainfall, especially above 150 millimeter in a week, this reduces the dengue risk because most of the dengue larvae or dengue mosquito eggs, they are often washed away because of the high water current that is created due to heavy rainfall. So moderate rainfall contributes more towards mosquito-borne disease, especially dengue. I hope all of you get it right. So by using such factors and AI-based tools, we can predict a dengue outbreak much early. Now guys, this is going to be the first year of this test of this dengue early warning testing. I honestly think UPSC will have a great chance in prelims and both mains for questions related to this. In prelims, there is a very high chance UPSC can ask a direct question. Remember who has built it, what is the objective, what kind of tools they are using, what kind of factors they are comparing. So it's mostly temperature, rainfall, and humidity, right? And I hope you understand a similar kind of model can also be made for other mosquito-borne diseases in the future. So guys, this is technically everything that I had to discuss with you. Acha, what is the significance? I'm sorry, this is one more part. The significance is it can extensively help in improving the better urban health management, because urban areas are the ones which are more vulnerable to such diseases. We can introduce timely interventions. We can provide proactive support. You guys know dengue involves sometimes platelet, a transfusion is required. So we can, timely intervene, ask more and more people to voluntarily come up, arrange more platelets. Then in the blood banks, then climate change studies. We can also study how climate change is inducing more dengue-like conditions or more health hazards in the country. And lastly, we can also prepare strategies for global spread if there is a chance of any global outbreak, because there are some countries which due to global warming are going to face mosquito-borne diseases for the first time. So they can really get a lot of help from the data from such models, and we can provide them strategies for protecting their own people. So this can also help us in creating global collaborations. And guys, this concludes my discussion for this week's current affairs on science. So guys, we'll be meeting next week. I hope whatever I've covered today, you have been able to understand. Please write in the comment what else you want me to improve on. I've been reading the comments lately, and I want you guys to contribute as more as you can in terms of your feedbacks, in terms of your suggestions. I'll be reading them and I'll be glad to have all those feedbacks. All right, guys, all the best. Thank you.